How's it going, guys? This is the module 1.1 to 1.2 quiz review video. I'm going to go over a few problems on the homework that I think will be kind of beneficial to know for the quiz. Do not only use this video to study. If you do, you probably won't do too well. Make sure you do all the homework, all the notes. We try our best to make sure the quizzes and the quizzes and the test reflect what you saw in the notes and the homework. So make sure you do not just study this. It's just a little helpful video that kind of hits on a little bit of everything that's on the homework. All right. So these are all homework problems. This is number 4. So number 4, we have 3x minus 19 is greater than or equal to 7x plus 13, or 31 minus 4x is less than 3x plus 10. So this is an or problem. So remember, there's a difference between and or. If it's an or, that means either one works. So I need the left inequality to work or the last one. So I just need one of these two inequalities to work. So let's go ahead and solve these inequalities out and see what we get. 3x minus 19 is greater than or equal to 7x plus 13. We're just going to add like terms, or subtract the 3x over, subtract the 13 over. You get negative 32 is greater than or equal to 4x. We add like terms, divide by 4, negative 8 is greater than or equal to x. So if negative 8 is greater than or equal to x, which is the same thing as x is less than or equal to negative 8. It's the same thing. Now let's solve the other inequality. 31 minus 4x is less than 3x plus 10. Same thing, add like terms. I'll subtract the 10 over to get 21, add the 4x over to get 7x. To get that 3 is less than x, we divide by 7, or just x is greater than 3. Same thing, I'm just writing it so it's told in terms of x rather than the number. It doesn't really matter. Same thing. Anyway, this is an or problem. So talk a little bit about a little more about or. When we say the word or, we're saying we want x to be less or equal to negative 8, or x is greater than 3. I just need one of them to work. I don't need both of them. I just need one or the other. If it's both, great. It doesn't matter. I just need one of them to work. So because it's an or, and because I only need one of them to work, what I'm going to do when I graph my inequality, right, because I'm going to graph it first, I have negative 8, which is going to be a filled in circle, and I want everything less than that. So I want everything to the left here. And for x is greater than 3, it's strictly greater than 3, so I'll put an empty circle at 3. Now everything bigger than that. And that's my whole line. That's my whole answer. Because it's an or problem. Because it's an or, I don't need an overlap like with and. If it's an and, which I think is the next problem I'm going to do, I need an overlap. But because it's or, I just need one or the other to work. A lot of times you can think about it like in English. If I tell you guys, I want you to do page 2 of the homework or page 3, I'm saying do one or the other. You could do both, but I don't need it. I just need one of them, right? It's the same thing in math. I need x to be less than negative 8, or x could be greater than 3. I don't care. I just need one of them to work. So that's why this whole thing is my answer. And that inequality that I drew up there is the graph of it. Now, I have a compound inequality. These are always ands. So I'm going to break it up into 2 parts. 2x minus 17 is less than 3x minus 7, right? We have any type of compound inequality. What you want to do is you want to break it up, see what's being shared, and break it up this way. And it is an and, so I'm going to write that in the middle so I don't forget. And solve each one individually. For the green part, I can add the 7 over to get negative 10. Subtract the 2x over to get x. I'm just adding like terms and making sure the x stays positive. Just makes my life a little easier. And I get that x is greater than negative 10, or negative 10 is less than x, which is the same thing as x is greater than negative 10. And now I'll do the same thing for the blue part. Add like terms, subtract the 23 over to get negative 30. Subtract the 3x over to get 2x. And I get negative 15 is less than x, or x is greater than negative 15, same thing. All right, so that's what I have. It's an and statement. I'm going to rewrite this to make sure I don't forget. And is very picky because when I say I want x to be greater than negative 10 and I want x to be bigger than negative 15, I'm saying I need both to work at the same time simultaneously, right? So it's the same thing. I use that same homework analogy I said before. If I told you I need page 2 and page 3 of the homework, I need you to do both, not just one, not just page 2, not just page 3. I need 2 and 3. It's the same thing with inequalities, same thing with math. If I say x needs to be greater than negative 10 and it needs to be bigger than negative 15, I need both to work, not just one. So what I'm going to do, I'm going to take this inequality. I'm actually going to redraw the line down here. So this inequality, I'm going to redraw it. I'm going to do it over here. So I have negative 15 and negative 10. Negative 15 is smaller than 10. So we'll put that there. And the negative 10, I'll put it right here. All right, so before I actually graph it, what I'm going to do is I'm going to draw like a rough sketch underneath the line to kind of see, well, what's really happening. Because ands can be very tricky, so I always suggest drawing something away from the actual answer, like underneath the graph or above it, and then seeing from there what your answer is going to be. So for the green one, I want x to be bigger than negative 10. So that means that's what I want. I need x to be bigger than negative 10. So from negative 10 to the right, that's what my green line is going to be, or my green inequality. For the blue one, I need x to be greater than negative 15. So if I draw my blue line right here, I go to the right forever. I want everything bigger than it. So from negative 15 onwards is my blue inequality, this one right here. So now what I'm going to do is I'm going to look at both these inequalities and I'm going to figure out, well, what's the overlap of the two? So what you can kind of do, I guess a way to visualize it is if I put them on top of each other like this, what I'm looking for is where do they overlap? Where do they both work at the same time? And that's going to be your answer. So in this case, it's going to be from this empty circle. Remember, it's empty for the green one, so it's not present. Negative 10 is not in the green inequality. It's from negative 10 to infinity. So that red line is my final answer. Because that red line that I just drew, that is where they overlap. Right? If you look at this green one, and I move up the negative, oh, sorry, the blue one. If I take it and move it up to the green one, the blue and the green one, which is the colors I use for my inequalities here, I can see that, well, they overlap from negative 10 to infinity. And that is actually what your final answer is going to be. It's from negative 10 to infinity. Ands are very picky. You need both of them to work. I suggest drawing a rough sketch and seeing where they overlap, because that overlap is where your final answer is going to be. So in this case, it's from negative 10 to infinity. So from negative 10 to infinity is just another way to say x is greater than negative 10. And that's actually what your answer is going to be. X is greater than negative 10. All right, so now we're going to look at some graphs to figure out the domain, range, and behaviors. So for this one, the domain, for this problem, what I like to do for domains, I like to figure out, well, what's the smallest possible x that I have, and go from the left to the right and see if I'm missing anything. All right, so this line right here, I'm doing a different color. This line right here, that tells me I go to the left forever. So my domain is actually from negative infinity. And if I follow it to the right, so if I, let's do something like this. If I draw this line right here and I take it and I kind of go to the left forever, kind of checking every single x, right? Checking x at negative 10, then this is negative 9, negative 8, negative 7, negative 6, and so on. If I keep going from the left from negative infinity all the way out here, and I kind of slowly make my way across, I can see that I don't actually miss any x's at all. Every time like there's a missing circle, like in this one right here, it's kind of covered up somewhere else. It kind of another part kind of picks up the slack and it fills in that circle that you're missing, right? The one I circled right here, that one's missing. Well, that dot kind of picks it up. I do have an x. I do cross something on this line right here. And same thing. Just erase that one. Same thing here. So At an x of 0, I have an empty circle, but I follow that function. But this filled-in circle right there picks up the slack and lets me to have an x at x equals 0. And I can keep doing that same thing at this circle right here. I'm covered at the 6, 3 point. And then this line keeps going to the right and down forever. So I actually have a domain of all real numbers, right? And I do that line and kind of move it across to kind of show you that you do hit every single x on this graph. So sometimes I like to grab a piece of paper and kind of go x by x or y by y to kind of see, do I have something that is on that line, right? And now for the range. So I'm going to look at the range. Ranges go from down to up. So I'm going to do the same thing. I'm going to start with my smallest possible y. So if I look down to go to up, this line right here, that goes down forever. So I know that I start at negative infinity. And now I need to figure out, well, do I miss any y's? Do I have anything that I'm missing? And if I do, where are they and how high do I go? You know, it's a few things I need to figure out to know, well, what is my range going to be? So again, I could do the same thing. Grab a piece of paper, or in this case, I can draw a line and just move it up to see, am I hitting all the y's? So from down going up, this red line going down to the right, that gives me every single y all the way up. So I'm hitting every single y until I get to a y value of 3. At that y value 3, that line stops, and I'm picked up by the one I'm going to highlight in blue. This part right here kind of picks it up, and this green line still hits every single y all the way up to 10. Once I get to 10, well, I don't really have a y anymore. It's just not there. My graph stops going up. So that's when I range from negative infinity up to 10. So a lot of time, especially with range, domain might not be too bad, but range can be pretty confusing. Grab a piece of paper and kind of do what I did with that green line, just kind of moving it up one by one and making sure that line or that piece of paper is going through a point. If it doesn't, that means you're missing a y, and you have to go from there. End behavior. Erase this. End behaviors. You only have two end behaviors as x goes to infinity or as x goes to negative infinity. You either have one or the other, or you have one, the other, both, or neither, right? So if I look at this graph right here, I go to the right and down forever. So I am going to one end of the graph. X does go to infinity. And as x goes to infinity, f of x I can see is going to negative infinity, right? If I redo this here, as x is going to the right forever, the y's are going down forever, or as x increases without bound, y increases or decreases without bound. So this is one statement that says as x goes to infinity, f of x goes to negative infinity. The other end behavior is if x goes to negative infinity. And in this case, it does, because this is going to the left forever. So as x goes to negative infinity, f of x is going to just negative 1. Do not put equals to. You don't have a value of negative infinity, so you can't just say for sure that it is negative 1. You say x is going to negative infinity, f of x is going to negative 1. I don't think we're going to be that picky about that on the quiz or test. So it's kind of what we're just, it's not a big deal. Just put arrows for all end behaviors. Okay, so those are my two end behaviors. You can never have more than two end behaviors. You can never, so this part in red I'm doing is wrong. You can never have x go to some number, like let's say 3 or something like that. This can never work. It has to be infinity or negative infinity. When it comes to end behaviors, x has to go to infinity or negative infinity. X going to 3 or negative 3 or something like that, that's something you'll see in a different class, not in this one. All right, so let's graph some functions. I want to graph this function from -6 to 3. The easiest way, this 2 right here, that's a y-intercept. Let's graph that. I have a slope of 5/3, so go up 5, right 3. Can't really go up 5 from there, but we'll say about right here. Why not? And then down 5, left 3, down 5 gives me to -8, left 3, right there. So what I would do if I'm graphing something like this is I would just graph the function itself. And I want a domain from -6 to 3. So from -6, so negative x value -6 is right here. 3 is right here. I want everything between it. So what I would do is just graph the whole function because it's pretty easy to graph a linear function and then erase everything you don't want, right? So erase everything you don't want, but don't erase the point. 5/3, so go up 5, 7 to 3. And then just make sure your endpoints are either filled in or empty according to what the problem says. -6 is a parenthesis, so I actually need -6 to be an open circle. So I'm just going to fix that. 3 is a bracket, it's going to be filled in circles. That one's fine. And there's your answer. Can you do anything else? I think that's it. All right. 19. Use interval notation to answer the question below for the graph of g of x to the right. So I'm asked, where is the function positive? So we say we want the function to be positive. We're saying you want y to be greater than 0. Not equal to it, but strictly greater than 0. 0 is not positive or negative, it's just 0. So I need to figure out, well, where's my graph positive? And if I look at it, my graph is positive everywhere. So I'll highlight in that light blue, because that's everywhere that's above the x-axis. So that means my function is positive from -infinity up to -8. The big U for or union, -4 to 1. And the reason we use parentheses here is because the -8, -4, and 1, they're ending at 0. If it ended some other place, like think problem 24 in the homework, if you look at that, the domain had a bracket around it, that's okay, because that means at -10, you're stopping at a positive number. That's fine. But instead, in this case, we're stopping at 0, so we have to put parentheses because -8 is not a positive number, or sorry, -8 gives you a y value of 0, which is not a positive number. When x is -8, y is 0, that's not positive, so that's why you put parentheses. You could have brackets, but not in this case. So now I'm going to deal with when the function is negative, that's everything below the x-axis. That's these parts in purple. Or really, it's going to be when y is strictly less than 0, not equal. So when it's negative, it will be from -8 to -4, union 1 to infinity. So when it's y less than 0, when from -8 to -4, and 1 to infinity. We use parentheses because when x is -8, -4, and 1, there it's equal to 0, so you cannot put brackets, it has to be parentheses. Where is the function increasing? So when we say that when is the function increasing, what we mean is we're asking when are the y's going up? So remember, you always read graphs left to right, least to greatest. So we're asking as the x's increase, where are your y's increasing at the same time? So what I'm going to do is look at the graph and read it left to right. And I'm just going to see, well, where does my graph actually go up as I go left to right? And that only happens on this interval right here from -6 to -2. That's the only time your y's increase when your x's are increasing. So it's -6 to -2. Remember, the words increasing and decreasing, they're relative terms. So you have to use parentheses. You cannot use brackets when we're talking about increasing or decreasing, right? It's from -6 to -2. You can't say -6 by itself is increasing or -2 is increasing. It has to be an interval from -6 to -2 is increasing. And where's the function decreasing? That's pretty much the opposite. When are the y's going down? So if we look at the graph, the y's are decreasing, but when the function is decreasing from -infinity all the way down to -6, and from -2 to infinity, right? That's when it's decreasing. So we can say from -infinity to -6, and from -2 to infinity. All right. So again, increasing, well, first actually you read graphs left to right, least to greatest, and we say when is a function increasing? We're looking, well, when you read the graph from left to right, when do the y's go up? And when you read the graph left to right, the function's decreasing when the y's go down. Now, example 20, answer the questions below the graph of f of x at the right. So where's the rate of change positive? So rate of change is a little different than increasing or decreasing. So average rate of change is positive. We only care about the endpoints. We're asking when do the y's go up. So where's the rate of change positive? There's a lot of cases, but I'm gonna give some weird ones to make sure you understand what it means. So from -8 to +2, which is like 2, 1 actually. That rate of change is actually positive. So from -8 to 2, and rate of change, you always put brackets because rate of change only cares about the beginning and the end. As long as what's happening in the middle is continuous, it doesn't matter what happens in the middle. So from -8 to 2, the average rate of change is positive. So I went from a y value of -6 to a y value of 1. My y is increased, give a positive rate of change. And now, where's the rate of change negative? That's a little different. I'm asking when do the y's decrease over a continuous interval? So in this case, let's give another weird one. Let's do -4 is right here, -4 to 4. The y's decreased, even though between it I did go up and then I dipped back down, then I went back up again. All that matters is that I ended up with a smaller y value than I began with. -4, I began with 3. +4, I ended with 0. So my y's decreased over time, or not over time, sorry, they decreased from the beginning to the end, and that's all that matters for rate of change. So that's why the rate of change is from -4 to 4 is negative. It's continuous, and at the same time, my y's decreased from -4 to 4. Give an interval in which the average rate of change is 0. Let's do that same one, -4 to 5. So rate of change is 0 means you started and ended with the same y. There was no change. So if there was no change from beginning to end, well, your average rate of change is 0 if there was no change. So -4 to 5, average rate of change is 0. How many relative minimums does the graph have? So remember a relative minimum, what that is when the graph goes down, it hits a minimum, then goes back up. You need both sides. It needs to go down, then it needs to go back up. So how many do I have? Well, I can see I have one here and one here. I don't have any others, so I have 2 relative minimums. And what is a relative maximum for the graph? We actually have 2, right? We have one right here and one right here. I'm going to give the more pointy ones. I think it's easier to see what the value is. So when we say what is it, we're asking for a value. So the value of that relative maximum is 6. So maximum is 6. It happens at 6, 6. You could give the other one. I think they're both actually equal to each other, but that's your maximum value. I'm not going to do all of these down here, the average rate of change on the intervals. All you need to do, I'm going to show you a few, or just one really. All you need to do is just find the slope from one point to the other. -10 to -6. So -10 is right here. Or it's not do that was a little too easy. Let's do 1 to 7. So 1's right here, 7's right here. I want to figure out what's the average rate from 1 to 7. I don't care that it goes down and back up in the middle. That doesn't matter. All that matters is that I started at 5 and I actually ended at 5 too. It's 0. All right, so that's 1. That was the bell, and get finished up. And that's all you have to do. Find the y's, connect the points, and find the slope where the riser run over that. Last one, we're going to do it pretty quickly. So average rate of change of this f of x over this x value, over those x values. So between 2 and 5, I think a better word to use is from. Average rate of change from the x values 2 to 5. It's not a big deal. We want the average rate of change of this. So what you're going to do is find f of 2, because what you need is you need points. f of 2 will give me 2 times 2 squared minus 5 times 2 plus 4, which is, that's 2 squared is 4, 8 minus 10 is negative 2, plus 4 is 2. Solve it out, you get 2. F of 5 is 2 times 5 squared minus 5 times 5 plus 4. 5 squared is 25 times 2 is 50, minus 25 is 25, plus 4 is 29. So I'm doing it a little quickly, but all I'm trying to do is figure out the y values, because these right here are x's. So what I have now is I have the points 2, 2 and 5, 29. I have these points, lemon x1, y1, x2, y2. All I need to do now is use the formula y2 minus y1 over x2 minus x1. Just plug them in. You get your answer. So we can do 29 minus 2 over 5 minus 2, which gives you 27 over 5 minus 2 is 3, which is a positive 9. So that is the average rate of change. So if we give you a function without the y values, you just solve for the y values, plug into the average rate of change formula, solve it out. So this video is a lot longer than I expected it to be. Hopefully this was helpful, guys. Good luck on the quiz.